Hey there! Welcome to this exploration of the fascinating world of artificial intelligence. Have you ever wondered how AI actually understands the world around us? How do these complex systems learn and reason about the information they process? Today, I'm diving into one of the most fascinating and honestly often overlooked topics in artificial intelligence. It's a field that bridges the gap between raw data and meaningful understanding: ontological engineering. Now don't let that fancy term scare you off. It might sound intimidating, but the core concept is surprisingly straightforward. Ontological engineering is just about teaching AI what things are, essentially building a structured knowledge base that the AI can then use to reason and make decisions, and how they relate to each other within a specific area. It's about defining the relationships and connections between different concepts within a particular domain. Think of it as building a detailed map of knowledge for AI to navigate, a comprehensive blueprint that allows the AI to understand the context and meaning of information. Let's take healthcare as an example. Imagine trying to explain basic medical concepts to a computer. Humans just know that flu is a disease, fever is a symptom, and rest helps. We have this inherent understanding of how these concepts relate to each other. But for AI, none of this is obvious. It doesn't have the same background knowledge or common sense that we do. I have to spell out every concept and all the connections in a clear, logical way, defining what a disease is, what a symptom is, and how they relate to each other. And that's what ontology is all about. It's about creating a structured representation of knowledge that AI can use to understand and reason about the world. So what does this actually look like in practice? How do we represent this knowledge in a way that AI can understand? Imagine a web where every piece of knowledge, every concept, every entity, every piece of information, like symptoms, diseases, or treatments in the context of our healthcare example, is a node, a central point representing a specific concept. And the lines between them show how everything connects. These lines represent the relationships between the different concepts, defining how they interact and influence each other. This structure helps AI understand not just data, not just the individual pieces of information, but the meaning behind it. It allows the AI to understand the context and significance of the information it's processing. Why does this matter in the grand scheme of things? Why is ontological engineering so important for the future of AI? Because with an ontology, AI can make smarter decisions, it can reason more effectively, and draw more accurate conclusions, link information more intelligently, connecting disparate pieces of data to form a more complete picture, and even make educated guesses. It can infer new knowledge based on the relationships and rules defined in the ontology. For example, when you tell your smart assistant, "I have a headache," and it understands the implications of that statement, and it offers helpful advice, suggesting remedies or asking clarifying questions, that's probably because there's a health ontology at work behind the scenes, guiding the AI's understanding and reasoning. The process usually starts with defining the domain, carefully outlining the scope of knowledge that the ontology will cover. What world are we mapping? What specific area of knowledge are we trying to represent? Next, I pinpoint the key concepts, identifying the most important entities and ideas within that domain. Lay out their relationships, defining how these concepts relate to each other and interact within the system. Set up logical rules, establishing the constraints and principles that govern the relationships between these concepts, and model everything using tools like OWL, the web ontology language, a standard language for building and representing ontologies. In the end, ontological engineering helps AI systems move beyond just crunching numbers, beyond simply processing data and performing calculations. They start to understand context, meaning, and even your intent. They can truly understand the information they're processing and use it to make informed decisions. This makes them way more accurate, useful, and honestly, way cooler to use. It unlocks a whole new level of potential for AI applications. Curious about the building blocks of AI and how these systems are designed to learn and reason? Drop a comment below. I'd love to hear your thoughts and answer any questions you might have. Thanks for watching, and I'll see you in the next one.